I'm Tom Temin, and my guest is Mike Cook, the Senior Vice President of North American Sales for Hughes and EchoStar Company. And our topic today is bringing managed broadband services to the federal government. And Mike, I guess we should begin with the beginning, and that is Hughes is often thought of as strictly a satellite company, but over the years you have morphed into much more than that. Tell us what it is and how it happened.
Well, Tom, first of all, it's great to be here. You really are going back quite a long way when you talk about Hughes as a satellite company, because more than 10 years ago now, we embarked on a program to provide managed network services to a wide range of different customers. And when we did that, we decided that we really should embrace all transport technologies. So obviously satellite is still a big part of the mix, but today we provide services to people using cable, using DSL, using fiber, using 4G services. And the other great thing is we put them all together and we can give people multi-transport networks which enhance reliability and enable us to really tailor the network to the needs of the individual customer.
So basically then you cover space to the last mile or the last inch inside a building.
Yeah, absolutely, yeah. Very small space, exactly right. Yeah, so basically it's an Ethernet port, and the customer plugs in their routers and all the other things that they need to provide their services on top of the transport and the managed service that we provide.
And so what are the services built into it that it can know what is the best transport for the best situation for a given customer? Is that something that happens transparently for the customer?
Yeah, it does. I mean, we have a team of engineers that will sit down with the customer, understand what it is they're trying to do with their network. Again, you know, what the parameters are. Are they trying to economize and really just have basic transport, or are they trying to provide a high availability, high reliability network? So our engineers sit down with the customer and we'll understand that and come up with a network design which is tailor-made for that individual customer's needs.
Now, in the federal government, you have a lot of distributed organizations. You have some places with offices in every state, maybe multiple offices in every state, or even around the world for that matter. So how does that all work so that they get what they need to the individual endpoint, again, regardless of transparently as to what the transport is?
Yeah, so our expertise actually, Tom, is dealing with the distributed enterprise. So if you look at our commercial customers, and by the way, we're supporting somewhere in the region of 300,000 endpoints across the country today. Managed devices, so we can actually see into the device, understand what's going on in the network, and so on. In the distributed enterprise, we're dealing with major retailers. For example, people like CVS and TJ Maxx, big restaurant chains like Yum Brands, and so on. And we are able to look at across the country the availability of terrestrial services and pick the right transport. So, again, if a customer just wants an economic, relatively slow speed transport, then we can look at where DSL is available, and it's available in a lot of places. When it's not available, we'll look at other transports like cable and so on. Or if a customer really wants to have a high speed pipe, and these days, even in a quick service restaurant, we're finding that the need from the customer is to have multi-megabit services. So it's not uncommon for us to design a network that's a minimum of 6 megabits per second across the country, or a minimum of 10, or even in some cases 50 or 100 megabits per second.
So that might be helpful if they have online ordering, the equivalent of citizen services that you would call it in the federal government.
Yeah, absolutely right. Again, and the parallel is really there. The bottom line is that, in the old days, if somebody wanted a reliable network, they'd probably use T1s. Many years ago, the world bypassed T1s, and T1s really aren't good enough any longer for the majority of our customers. And what we're seeing is that federal government is exactly the same. What used to 1.5 megabit pipe used to be good enough. Then they sort of went to 2 1.5 megabit pipes, and the cost of that is enormous compared to, for example, a 10 megabit per second cable or fiber service.
Now, when you have multiple transports from satellite to fiber to copper and so forth, does that help in the area of continuity of operations, failover if one link should fail, or there should be some kind of an issue?
Yeah, absolutely. So again, if somebody's looking for high availability, we will typically put at least 2 different transports into an individual location. Again, for example, that could be DSL and 4G, or it could be cable and 4G. In many cases, our retail customers are looking at 3 transports. So it's not uncommon for us to put, for example, cable and 4G and satellite in as a combination. We don't like to talk about them being backup services because in reality, all three of them will be carrying traffic all of the time, depending on the application. And then in the event of a failure of one of those transports, then all of the traffic is picked up on the ones that are still there.
All right, so you have good reliability then, in other words.
Absolutely. And one of the most important reasons why people need that reliability is because of the increasing dependence on cloud services. In the old days when the application was running in the branch, it was relatively okay if the network went down for a little while because the branch would still be able to operate. But in today's world, where most of the applications are in fact running in the cloud somewhere, you just can't afford for that network to be down even for a second.
And just talk a minute about the managed aspect of the managed service. You described the transport and the services. How does the management work?
Well, management starts really with the selection of the transport, because if you can imagine, in order to build a nationwide network, we have to deal with every telco across the country, every cable company across the country, every wireless provider across the country, because at every branch there's going to be a different choice. And so the first thing is we have to deal with all of those people, and we built the infrastructure to be able to deal with those people as often as possible using e-bonding. But where we can't do that, then we literally talk to the individual providers. So we're managing all of that in the event of a failure. We're on the phone and we're making sure that there is resolution to whatever the problem is. And then the next layer is that we obviously provide the device that sits in the branch, and today the device that we provide is what we call a managed firewall, because security is a big deal. Mm-hmm. And we don't want people from the outside getting ingress into the network and being able to get through our network into the branch. And so we have a very sophisticated firewall that we can see into. We're constantly managing that, so we're looking at it the whole time to make sure it's up and to make sure that everything is working well.
And what are the economics relative to, say, T1 lines or some of the other standard types of offerings?
The economics of broadband really are quite phenomenal, and it's a sort of surprise to me that our government customers haven't really hooked on to broadband in a bigger way. Because, as I say, if you want a 3 megabit per second service, you have to have two T1s. The cost of two T1s is pretty high. You can get a 10 megabit per second cable service for a lot cheaper than one T1. So, if people want bandwidth, and they do need bandwidth, why wouldn't they adopt broadband in a much bigger way than they have so far?
Mike Cook is the Senior Vice President for North American Sales at Hughes and EchoStar Company. I'm Tom Temin.